Hi, student. I hope you understand that today's topic is about selection sort technique of sorting an array. I want to show you how we can apply this technique to sort an array using Java program. So without wasting time, let us start. Selection sort means we have to select some element or one element and we have to see whether it is in the correct position or not. Simple. If it is not in the correct position, then we have to look for the correct element in that positions. Our target is to arrange this given array 8291 in ascending order using selection sort. Ascending order means the smallest element will come first and the largest element will go to the bottommost cell or the last cell. Since our target is to bring the smallest element forward, so what we have to do, among the unsorted portion of the array, at the very beginning, the whole array is unsorted. So among the unsorted portion of the array, we have to select the smallest element and bring it to the front. We have to select the position and then check whether it is the correct element or not. Now, let us see. First, the definition of selection sort. What is the definition? Tells us in selection sort, the smallest element of the array is selected in every round and inserted to its appropriate position in the array. Why they said smallest element? Because our target is to arrange the array in ascending order. So the smallest element should come first. So from the unsorted portion, every time we'll look for the smallest element. So it means divide the array into two halves. It is an in-place comparison sorting algorithm. In this algorithm, array is divided into two parts. The first is the sorted part and another is the unsorted part. And you will see I have marked the sorted part in blue color. So it will be easy for you to understand. Step by step of selection sort array given as an example array, which is 8291. We want to arrange them in ascending order. You all know when you store data in a single dimension array, every element has its own index position and it starts from 0. So index positions are 0, 1, 2, and 3 elements given as 8291. Our target is to arrange in ascending order using selection sort technique. So let us start. This is I0 round or the first round. You can call it round 0. Now, this is very important. I0, that means we have to select index 0 and then check whether it is correct or not. So index 0 is selected. Now our target is to arrange in ascending order. So we have to see whether the smallest element is present in the 0th cell or not. We will use a variable m to store the index of the smallest element. And then we will compare with the index of the smallest element and the index that we have selected. Be careful, we have selected 0. Now, if you ask me why we have selected 0, because value of I is 0, round 0. We have selected index 0. We have to choose the smallest element because our target is to arrange in ascending order. And at present, the whole array is unsorted. So since whole array is unsorted, so we have to look for the smallest element from the whole array. Which is the smallest element? 1. What is the index of is? 3. So I is equals to 0, m equals to 3. Since the value of I and m are not same, so we have to interchange their position. So how to interchange? Here is it is 1 will come to 8th position, that means 0th position, and 8 will go to the last cell, that is cell number 3. Now you see the first cell get its target value, so it become in blue color. Now the array, one part is sorted, another part is unsorted. 0 is the sorted part, unsorted part is 1, 2, and 3. This is the end result of the first round or I0 round. Array is not fully sorted. At least we get the target value in the first cell. With this result, we start our second round. We call it round 1 or value of I is 1. These are the index. Now value of I is 1. So we have to select index 1. So we tick index 1. We have selected index 1 means value of I is 1. Unsorted portion is index 1, index 2 and index 3 is unsorted. Index 0 already sorted. Now from among the unsorted portion, that means 2, 8 and 9, we have to find out the smallest element. Which one is smallest? 2 is the smallest. What is the index of it? 1 is the index of it. We select index 1. Now among index 1, 2 and 3, we choose the index of the smallest element and the result is 1 itself. So this is a situation which is called no swap because there is no one with whom we can interchange. Why? Because value of I and value of M is same. So we will leave it as it is. But now the sorted portion is index 0 and index 1. Unsorted portion is index 2 and index 3. This is the end result of I1 round, but still the array is not fully sorted. Now half of the array is sorted, half of the array is unsorted. With this result, we are going to start our third round or the final round. We call it I2 round. Since the value of I is 2, so we have to select index 2 and start. Index 2 is selected. Why? Value of I is 2. We have selected index 2. So among the unsorted part means cell 2 or the index 2 and index 3. Among this portion, which one is the smallest element? 8. What is the index of it? 3. Now, I is 2, index is 3. They are not same. We have to interchange 2 and 3. So let us swap index 2 and index 3. Once we interchange them, we have a nice answer in front. Now the array is fully sorted. Now the color is totally blue. This is the index of the final array. Array is sorted. Now how many round do we require? We have started from 0 round, I0 round. I hope you remember. Next one, I1 round. And this is I2 round. Means there are 4 elements. We require 3 round of sorting. So if there are 10 elements, we required 9 round of sorting. If there are 100 elements, we required 99 round of sorting. Now this is the final result. Array is sorted with 0, 1, 2, 3. This is the index. Now let us see this, how we can apply in a Java code. How we can apply it in a Java code. Our example array is 8291. And the length is n equals to a dot length. Obviously, length is 4. Now, I hope you remember, we require 3 round of sorting. So 3 round means first round was I0 round and the last one is I2 round. Now what is written? The condition given here, n minus 1. Means n is the length of the array, which is according to this example is 4. So 4 minus 1 will give us the result 3 or less than 3 means 2. So we required I0 round, I1 round and I2 round. Now we have selected m. That means we assume m equals to I. What is the value of I? At the very beginning, the value of I is 0. So m equals to 0 that we have selected. Now let us check it in the inner loop. We are starting our inner loop, that is J loop, with j equals to I plus 1. That means we have selected the first cell. So we are starting our checking process from the very second cell, that is I plus 1 and cell. How long we have to continue? Up to n. Now here we are checking aj is less than a of m. Now just see this example. M at the very beginning means 0. So a of m definitely representing element 8 at the very beginning. Since j is starting from I plus 1 position means 1 position. So aj actually means a1. What element is there in a1 at the very beginning? Element 2. So at the very beginning, at the first round of checking, element 2 is being compared with element 8. So obviously element 2 is less than element 8. So the index of element 2, that is 1, will be stored in M. So in this way, we will definitely find out the index of the smallest element. So what is the purpose of inner loop or J loop? Is to find out the index of the smallest element. Now, once we have this result, we can compare it with the value of I. If M and I is not same, not equal, then we have to interchange or swap them. Now, we have to interchange or swap them using third variable T, just like what we have done in case of bubble sort. T equals to A of I. We stored the value of A of I to T. Then A of I equals to A of M. We are interchanging with A of M because M has the index of smallest element. I is the very first cell at the very beginning. So these two element interchange their position. This is the only the sorting code. After that, we have to display the final sorted array. Now let us explain you selection sort using a BlueJava program. The question that you can see on the screen. Write a program to accept an array of 10 numbers and arrange them in ascending order using selection sort technique. Now you have to accept an array. The previously I have shown you an example where you assign only four numbers. Now here it is much more serious. We have to accept the array, then you can do it. We are shifting to Java program. I have already written it so that we can save some time. Import java.util, you know this line that we have to import util package because this package consists of scanner class and we require scanner functions or the functions belong to the scanner class to accept data. Now here we declare the array. I'm selecting it. Here we are declaring the array of size 10. I and L are the variable we required in the loop. J also required in the loop. Now let us start. Now first job is to accept the data or store the data in array. So we are running a for loop starting from 0 less than 10 because you know the index start from 0 and the last index is 9, that is less than 10. That's why we are giving a message, enter I plus 1 number. Why we write I plus 1 number? Because the value of I is 0. So I plus 1 means 0 plus 1. So 0 plus 1 means the enter first number. So message will be a little bit attractive. Enter 1 number, enter 2 number. That will help the user to understand what we have to do. So A of I equals to sc.nextInt. We are accepting the first number and storing it in A of I cell. Now after the acceptance is over, that means after the storing job is over, we have to sort it using selection sort technique in ascending order. I0, I less than 10 minus 1. Just now I have said that if there are 10 elements, we have to perform 9 round of sorting. That's why 10 minus 1. We have selected the value of I to M. J is starting from I plus 1. If J less than 10, that means we are continuing up to 10. That is the condition. J plus plus will increase the value. What is the purpose? We are finding out index of the smallest element because we want to arrange the data in ascending order and the smallest element will come first. So that's why we are looking for index of the smallest element. Now, if that index of the smallest element is equivalent to the value that we have selected as I, if I and M is not same using third variable, we are swapping it, interchanging it. So this whole code is actually the sorting code. After that, we are displaying the final array. That is I equals to 0, I less than 10, I plus plus is the for loop. We are displaying the final array. Name of the array is A of I. Now, let us run the program. You know, we have to compile the program, no syntax error. Click on the close button. Let us close these questions. Here it is. Right click on this void main. Enter 10 number. And then it is written enter 1 number. That means it will help us to enter the number. I am entering the number first 6. Then I give 9. Then I'm giving 12. Then I'm giving 90. then I'm giving 456, then I'm giving 7, then I am giving 71, then I am giving 111, then after that 10, after that 2. This is the last number 2. 2 is the smallest one. Now see, the array is sorted. First one is 2, 6, 7, 9, 10. In this way, we can arrange them in ascending order. So this program is running perfectly correct way. So our job is to arrange the data in ascending order is fulfilled. Once again, have a look to the program. Just double click on it. Let me go to the very beginning. If you want to see it, check it once again. We declare the array, then we declare scanner object. Now using for loop, we are accepting the data. This portion is the input portion or accepting portion. We are accepting and storing the data in the array. Next block is the sorting block. Using I and j, outer loop and inner loop, we are sorting the data. Once the sorting is over, we are displaying the data using this for loop. Thank you for watching this presentation. If you have any question, you can ask me. So bye bye for today. See you next time.